Well, here we are at Lowell Observatory in Flagstaff, Arizona, and joining us today is Kevin Schindler. He's the outreach manager at Lowell Observatory. Thank you for being here.
Great to be here.
So can you tell us a little bit about the history of Lowell Observatory?
Sure. Lowell Observatory goes back to 1894. A fellow named Percival Lowell, who came from a very wealthy family. For instance, politicians, writers. His brother was president of Harvard for 24 years. His sister was the poet Amy Lowell. So came from a very wealthy family. He studied mathematics at Harvard, because if you were Lowell, you studied mathematics at Harvard. And then he spent some time in the family business, went overseas, and by the 1890s decided he wanted to build an observatory to study the supposed canals that Giovanni Schiaparelli, the Italian astronomer, had discovered in 1877. So in 1894, Percival Lowell sent a scout named Andrew Douglas out to Arizona. It was a territory, wasn't a state till 1912. And Douglas's job was to take a 6-inch diameter telescope, drag it around the territory, Tombstone, Tempe, Prescott, ended up here in Flagstaff, set the telescope up in different sites and do site surveys, testing the sky for the quality of telescopic viewing. And Douglas spent several months out here and ended up in Flagstaff, decided Flagstaff was a pretty good site, and so Lowell decided to set up the observatory here. A high elevation at about 7,000 feet, so there's less atmosphere to distort the viewing. It was pretty close to the train, so transportation was easy. So a lot of different factors in setting it up here.
What was the population of Flagstaff at the time?
About 800 people,
wow.
And there was no electricity here.
And today?
Today about 57, 60,000, something like that. So the place has grown a lot. When Lowell came here, one of the reasons he went from Massachusetts out here to Arizona is that if we go back in time to the 1890s, electricity is becoming widespread in the cities. And of course, that's where observatories historically were, where the universities were, where the cities were, where people lived. Right. And so by the 1890s, you had light pollution from electricity. So Lowell was one of the first to realize, if you're going to build an observatory, do it away from where the cities are. And so that's why he chose Arizona. There wasn't electricity in Flagstaff yet. Flagstaff was an outpost in the Wild West, really.
Yeah.
And so decided to set up the place here.
Interesting. So the observatory, of course, is famous for the telescope we're standing in front of. Can you tell us a little bit about the telescope?
Sure. This telescope was not the original one that Lowell used. He actually borrowed one from Harvard College Observatory, and then one from a telescope maker named John Brashear of Pennsylvania. He borrowed those for the first season here at the Arizona, and then in 1895 he decided to order this telescope from the best telescope maker of the time, Alvin Clark and Sons. And Alvin Clark and Sons specialized in this type of telescope, which is a refractor, which uses lenses as opposed to reflectors, which use mirrors.
Sure.
And so this was a typical telescope of that time. And so while this telescope was being finished, Lowell decided to abandon the operations here in Flagstaff and find another site to see Mars the next year, because Mars was going to be at a nice opposition, but it would be pretty low in the sky here in Flagstaff.
Okay.
Plus that first year here was cold like today, but also had a lot of snow.
Okay.
And so they decided to find another place with a better climate.
Interesting.
And so they built this telescope in 1896. It was first used in Mexico to study Mars. And then in 1897, Lowell decided to bring it back up here and decided, although the weather can get a little chilly here and snowy, this is a pretty good site for an observatory. So this telescope has been sitting on this pier since 1897. And in fact, in just a couple months, we're going to be taking it off of here for a retrofit to rebuild it and renovate it. And for the first time in more than 117 years, it's going to come off this pier piece by piece.
Wow. And
that's going to be a pretty fabulous thing. But the reason we're doing that is because it's been used so much through the years. Percival Lowell's studies of Mars, perhaps the most important discovery made not only here, but at Lowell Observatory, started in 1912 with V.M. Slipher's first detection of the expanding nature of the universe. This was not the telescope used to discover Pluto, but it was critical in the search for what we know today as Pluto. The last major research done with the telescope was mapping the moon for the Apollo program. So several of the astronauts who walked on the moon came here to Lowell Observatory to do their training in the 1960s and look through this telescope.
Oh, excellent. So our students might be noticing that this telescope is quite long compared to the ones that we saw at Palomar
Yes.
Observatory. Can you tell us a little bit about the difference between a refracting telescope as opposed to a reflecting telescope? I know you said something about lenses.
Sure, a refracting telescope uses lenses, and if I can make a mini telescope right here, this is the telescope, so the light comes in here and the eyepiece is down here. So in a refracting telescope you have a couple of lenses up here, and light passes through the lenses refract or bend the light till they come to the focus down at the eyepiece. So the wider the tube, the longer it has to be for it to come in focus. The problem with that is structurally, you can only build something so big and it's going to sag under its own weight.
Right.
The biggest refractor ever made and successfully used was 40-inch at Yerkes Observatory in Wisconsin. For a world's exposition, a 50-inch was made, but they couldn't use it. It was just too big and sagged under its weight. With reflectors, you have the light coming in here, but instead of lenses, you have a primary mirror down at this end. And there are a lot of different configurations for this, but a typical way is that light comes in, hits that primary mirror, and that bounces back to a secondary mirror that's suspended in the tube, and that bounces back to, say, an eyepiece or equipment. And so the advantage of that is that you can make the mirror wider, because the mirror or lens is how you're gathering the light. You can make it wider, but the tube doesn't necessarily have to be longer. You're bouncing the light back and forth inside. So these refracting telescopes, historically, they were sort of believed to be better for doing planetary work in detail, and reflectors were better for collecting lots of light,
for very
big light
faint
buckets
objects.
for faint objects. But today, most modern, in fact, all modern research telescopes are reflectors.
So because of the size of the telescope, if the observer wanted to point it at something lower on the horizon, how did they get access to the eyepiece?
Sure, and that's a great question, because the eyepiece is right down here at the end. In some observatories, you have an elevator floor that lifts you up or down to the eyepiece. In this case, the telescope is kind of down in this pit, so we're a little bit lower. And then as you swing the eyepiece up, because the telescope's looking at something lower, you step up on these steps. And then if the eyepiece gets too high, then we have observing ladders that you can climb up the ladder, sit on the ladder, and be looking through the eyepiece. Because this is the days of research before modern technology. This was a pad of paper and a pencil, and looking hours, waiting for very quick moments of good seeing and sketching those details.
Sure. So when Lowell was seeing the canals on Mars, it was through this telescope that he was believing to see that. And his recreations of that show these very detailed canals that in reality ended up not being so real. So what's the history about the consequences of his belief on those canals on Mars?
Well, you know, Percival Lowell had such a legacy, and today it's like a lot of science. We look back 100 years and say, what a bunch of morons, what were they thinking? But, you know, science is a progress report. Based on what we know today, this is the best explanation of what we have. A perfect example is Pluto. When Pluto was discovered, it was more planet-like than anything else. But through the years, as astronomers found other bodies that weren't really completely planet-like, they decided to create a new classification called dwarf planets. The same thing sort of with Mars canals. Back in those days, Percival Lowell and others were seeing something, but they're illusory. They're not real features. But the interpretation was some sort of intelligent life created these to bring water down from the ice caps to the dying planet for the inhabitants there. Today we know that those canals aren't there. We've sent spacecraft up there. We don't see them. But the impact that Lowell had scientifically, so many astronomers either wanted to prove or disprove the idea of life on Mars, because there's probably nothing more compelling to not just scientists but the average person of the possibility of life in the universe. And so he really inspired, angered, in any way you want to describe it, got a lot of astronomers to want to study Mars a little bit more. From another standpoint, culturally, if you think about science fiction, Percival Lowell, because this is the 1890s, and he was a popularizer, much like Carl Sagan was years later, popularized astronomy. He would go on the lecture circuit, magazine articles, really popularize this idea that there's life on Mars. And then writers at the time like H.G. Wells, Edgar Rice Burroughs, These guys wrote novels based on this, which even more glorified the idea of life on Mars.
Right. And it all started right here.
It all started here, and you know, you don't see movies with Saturnians attacking Earth. It's always Martians.
Right.
It all started with Percival Lowell's ideas. So even though that's not what his intent was, it really had an impact on culture as well as the development of science.
And his legacy lives on.
It does.
Well, Lowell Observatory is a place with a lot of historical telescopes, so why don't we move on to the next one?
Sounds great.
Okay. So here we are at the famous Pluto telescope, and Kevin, can you tell us a little bit about it?
Yeah, we'd be glad to. This telescope goes back to really an idea that Percival Lowell had, that there is some ninth planet out there. And for years he searched for this planet. He never found it, but right before he died in 1916, he published an estimate of where he predicted it would be located. A decade later, the staff here at the observatory decided to start searching for this planet he thought was out there. And this telescope was brought in. The lenses were made by the same company that made the big Clark,
okay.
Alvin Clark and Sons, but the structure itself was made in-house. And it reminds us of the Clark telescope, but it's a lot smaller. Mm-hmm. But there's also something else a little bit odd. It has the tube, but there's no eyepiece to look through. That's because this type of telescope is called an astrograph,
okay.
and it's used instead of looking through an eyepiece to take pictures. And the way they would do it is, you see this big metal box-shaped thing here. This thing slides in and out. And so what they would do is go into a dark room and load a big photographic glass plate that has emulsion on one side. So it's like a big piece of film.
Okay.
And they would put that big piece of film in here in the dark, load it in that box, and then bring it up, slide it into the end of the telescope. So instead of having an eyepiece, you have this piece of film that's going to capture the image.
Okay.
And then what you would do is open the dome, point the telescope wherever you want to point it using the declination and right ascension wheel, so you know exactly where you're pointed. And you would take a picture of about an hour.
Okay.
And so you'd open the lens cap, and it would point in space for an hour.
Okay.
And then at the end of the hour, you would close this back up, take it back downstairs, and develop it. And then a few days later, you would come back and take a picture of the exact same area, and then put those two nearly identical pictures on a machine called a blink comparator.
Okay.
And look at every single dot from one to the other to see if it's changed position.
So looking for anything that's moving from one.
Exactly. So something the distant stars relative to each other are going to be in about the same position over a few days, but something really close to us, like a planet, is going to change position.
Okay. Well, what size of an area of the sky is this going to photograph?
It's about the size of your fist at arm's length, so 15 degrees or so.
Okay.
And so they systematically moved across a big swath of the sky searching for this.
In the area that they thought they might find this ninth planet.
So within a few months, Clyde Tombaugh discovered Pluto, and then for 14 years, he did the same thing, day after day, night after night, and searched about 90% of the sky in case there were other planets out there. He didn't find any others, but he did discover a lot of other things.
Oh, it's quite interesting. Well, thank you.
You're welcome.
All right, so here we are in the plate room where all of the photographic plates that are taken with the telescopes are stored, and Kevin is going to do something very special for us. He's going to show us the Pluto Discovery plate, at least the envelope that's covering the plate. Kevin, can you tell us a little bit about it?
Sure. As we talked about in the Pluto telescope dome, what Clyde Tombaugh would do is take a glass plate this size, there's one inside of this envelope, and it has emulsion on it. He would capture a picture, and then it's like one big piece of film, one big picture. He would develop it, and then there would be a pair to this that he took a few days later. So this is one of the plates he used to make the discovery.
Okay.
The amount of sky that's captured on this is about the width of your fist at arm's length. So you can imagine how many images it would have taken to cover the whole sky. And so after Clyde was done developing one of these, he'd go a few days later, capture an image on another plate, develop that, and then put both of these side by side on a machine called a blink comparator.
Okay.
And you look through a little microscope eyepiece at a small section of one of the plates, then you flip a switch and it moves over to a small section of the other plate.
Okay.
And what you're doing is comparing the same field of view and looking at all those dots, most of which are stars.
Right.
And out of maybe 200,000 or 300,000 on the whole plate, you're looking at every single one to see if any have changed position.
Okay.
And if it has, it might be a planet. It's going to be something that's closer to us and appears to be moving faster relative to those background stars.
And can you tell us a little bit about the effort that Clyde had to put into to ultimately come up with the discovery?
Sure. When he did this, this was one of hundreds of plates that he took pictures of and analyzed. So he would put these on the blink comparator and look through that eyepiece, and systematically, hours at a time, look through that eyepiece, look at the field of view, note every little dot from one to the other, and then change the field of view a little bit, and then compare everything in that. And so it would take him about a week to cover one set of plates to look at it. So on February 18th, 1930, about 4 o'clock in the afternoon, this was one of the plates he had in the blink comparator machine. The other plate he had is now on display at the Smithsonian Air and Space Museum. And so he had those two plates, and he was looking through the eyepiece and detected one of those points of light, or one of those points that appeared to change position.
Mm-hmm.
He measured the distance that changed over those few days' time and realized the amount that changed was proportional to what he expected something close to us, like a planet. And so at 4 o'clock, he realizes this. He calls to one of his colleagues to come and take a look. He looks at it and realizes it could be a planet. The next thing I did was go down to the director's office, and Clyde said, excuse me, Mr. Slifer, I think I found your planet X.
Oh, nice.
And Mr. Slifer, VM Slifer, said, okay, don't tell anybody. Let's do some more measurements to make sure that this is what it really is, a planet. And so whenever they took these big plates, they also had a secondary telescope with a 5-inch telescope. Mm-hmm. So they looked at that secondary plate to confirm what they had, because a lot of times they would find these dots that changed position, but it was a piece of dust.
Sure.
A variable star that was really bright. The next day you couldn't see it, but they found it on the backup plates.
Okay.
And so then Tombaugh's job, he was told, okay, tonight, now that we've found the location of this thing, let's go to the big Clark telescope.
Okay.
We can get a good image of it through the telescope tonight.
Okay.
And so Clyde Tombaugh is still light. He's trying to figure out what to do. He's a little anxious, so he walked downtown, had some dinner, picked up the mail, and it's cloudy.
Oh,
and he couldn't view through it, and he couldn't go to the Clark telescope.
Oh, wow.
So he went to see a movie, Gary Cooper movie in the Virginian, and he kept jumping outside to see if it cleared up, and it didn't. So he had to wait till another night till he could get on the big telescope, capture an image with that, because now he knew where to look.
Sure.
And they studied it for several weeks, and then by March, on what would have been Percival Lowell's 75th birthday, March 13th, they decided to announce to the world, yes, indeed, we do have a new planet.
Oh, interesting. Now, it looks like there's some interesting things written on the plate. Can you tell us a little bit about that?
Yeah, so you notice there's this yellowed portion here and then the white border. If I turn this around very carefully, this white border is this is a more modern acid-free envelope.
Okay.
The original envelope is this yellowish thing, and we've just taped the old envelope to the new one.
Okay.
Because this every time you do a photographic plate, you want to record the time, the exposure, all the weather conditions, so that you can recreate what you did.
Okay.
There's no point of doing it, just like anything in science, you have to record the data where you found something, or else you can't find it again.
Reproducible.
So exactly. So you have a lot of the basic information up here, the telescope used, the time you took the plate, and then this has a lot more information than usual, because after the fact, Clyde Tombaugh wrote this stuff on here, because this is sort of his account of the actual discovery.
Oh, nice.
And then at the bottom, which was typical of all the envelopes, he noted what else he discovered on the plate. So on here, he found 8 asteroids, 7 variable stars, 12 temporary objects, no comets, and oh, by the way, Planet X at last found.
Oh, very nice.
Which
and it looks like a symbol for Pluto ultimately added there.
And we can tell that this was written after the fact, because Pluto didn't get its name till a few months after the discovery.
Very nice.
So this is a really, it truly is a one-of-a-kind thing. That's why I have the white gloves, and I'm holding it very carefully.
Yes. Well, this has been quite a treat, and I want to thank you very much for allowing us to come to Lowell Observatory and see some of these famous telescopes and help our students understand the nature of the telescopes, especially the history of the observatory. So again, thanks very much, and we hope you join us again.